Example 5, solve the system of equations if possible. 3x plus y minus 2z equals negative 6, 4x plus 1/2 y plus 2z equals negative 5, and negative 3x plus 2y minus z equals 9. All right, so this is a 3-variable system of equations, but ultimately we're just going to use substitution and elimination. We can either stick just to substitution, stick just to elimination, or use a combination of them. I'm going to use a combination of them because I feel like it. But I want you to know that you can really use any method. Any method, as long as you're careful with your work, you're making sure you don't make mistakes. Either method will work, a combination of them, you can switch over. Sometimes the easiest thing won't be obvious and you just have to sort of try fiddling with it for a while and then you'll figure out what it is. So just play with it. Even if you're not quite sure what'll be easiest, just get started on it. Things will work out in the end. All right, so at this point I notice we've got 3x here and negative 3x here, so I'm going to add those two equations and I'll get cancellation. 3x plus y minus 2z equals negative 6, and negative 3x plus 2y minus z equals 9. We add those two together, put a line under it. 3x and negative 3x, they cancel out, so we've got 3y minus 3z equals positive 3. Let's divide everything by 3 to make it a little bit simpler. Y minus z equals not 3, but we divided by 3, so y minus z equals 1. Okay, now we'll come back to that in a few moments. And now we also might see, oh hey, there's a negative 2z here, there's a positive 2z here. We can add those ones together as well. 3x plus y minus 2z equals negative 6, and 4x plus 1/2 y plus 2z equals negative 5. Now, if you wanted to, you could have previously just gone to substitution once you had y minus z equals 1. You could have gone to substitution from the beginning, but I decided to start with elimination because I saw these things that could cancel out easily. 3x plus 4x, 7x, plus 1/2 plus 1 becomes 3/2 y. Negative 6 plus negative 5 becomes equals negative 11. Great. So at this point, we've got stuff involving x and y and stuff involving y and z. So if that's the case, we want to sort of overlap for the y. We want to be able to figure out what y is. So let's get everything in terms, let's get y the guy who's not going to be substituted out. So y minus z equals 1, we'll change that into z equals y minus 1, right? We subtract by y, then multiply by negative 1 on both sides. Z equals y minus 1. And over here, we can get what x is equal to, 7x equals negative 3/2 y minus 11, or x equals negative 3. We divide that by 7, so that will become 14 minus 11 over 7. Great. Now, that's not that friendly to substitute, but that's what we got to at this point. It might have been easier if we'd gone with a slightly different method, but we've got something. We can work it out. Might be a little bit more math than we were hoping to have to do. Might be a little bit more, number crunching, but it's not going to be that hard to work through. So at this point, let's figure out which one we want to plug it into. Let's choose 3x plus y minus 2z equals negative 6. That'll be fine. So 3x plus y minus 2z equals negative 6. Now, we know that x is equal to this stuff over here. So we've got 3 times negative 3. Oh, whoops. That was one big mistake here. Forgot to put that y down. Sorry about that, guys. So negative 3 over 14 times y minus 11 over 7, plus, we don't have anything substituting for y because we want y because we're going to solve for y at the end of this, minus 2 times, and over here, z is equal to y minus 1 equals negative 6. We start working this thing out. 3 times negative 3 over 14 will become negative 9 over 14y, minus 33 over 7 plus y minus 2y plus 2 equals negative 6. Let's compact some stuff together. We'll compact our y's to what we can. Negative 9 over 14 times y. And we've got the y here and the minus 2y here, so that'll become minus y. And we can't really combine 33 over 7 and 2 very easily without bringing in more fractions, so let's just subtract them to the other side, because we know eventually we're going to have to subtract them to the other side. So we subtract by 2 on both sides. Negative 6 minus 2 becomes negative 8. We add by 33 over 7 on both sides, so we get plus 33 over 7. Okay, now at this point, I don't like dealing with the fractions here, so at this point I'm going to just say, let's get rid of the fractions as opposed to trying to put things over common denominators. We're going to get rid of those denominators eventually, so we'll just multiply the whole thing by 14. So 14 times this whole thing. That'll get us negative 9y minus 14y equals negative 8 times 14 becomes negative 112, and 33 over 7 times 14, well, that'll cancel the 14 to just 2 times 33, right? The 14 divided by 7 becomes 2, so 14 times 33 over 7 is the same thing as 2 times 33, so that's plus 66, or that's negative. And so negative 9y minus 14y becomes negative 23y. Negative 112 plus 66 becomes negative 46. Divide by negative 23 on both sides, and we get y equals positive 2. Great. So there's our first thing. At this point, we've got these two equations. We've got our z equation and our x equation. So it's just a matter of plugging into those. Z equals, plug in our 2 for y, 2 minus 1. So z is equal to positive 1. That one's pretty easy. This one is a little bit more difficult. We've got x equals negative 3 over 14 times 2 minus 11 over 7. So that gets us negative 6 over 14 minus 11 over 7. Actually, you know, it's easier. Let's just cancel out 2 times 14, sorry. 2 over 14 becomes 7, so that'll cancel the denominator to just a 7 minus 11 over 7. So that gets us negative 6 minus 11. Whoops, wow. Let's go back a few moments to before I made that mistake. So negative 3 over 14 times 2, well, we can break this into 7 times 2. So the 2's cancel out, and we've got negative 3 over 7 minus 11 over 7. Negative 3 over 7 minus 11 over 7 gets us negative 14 over 7, because they combine. They've got the same denominator. So negative 14 over 7 simplifies to x equals negative 2. Great. So at this point, we found each of our values. We found our x value, our y value, and our z value. So in the end, we know that the point that works in all three of these equations is negative 2, comma 2, comma 1. Great. Now, once again, I'm just going to say you could have gone through, done this in other ways. You could have used just substitution. You could have used just elimination. You could have combined them in a different way than I did here. There might have been an easier way. There probably was definitely going to be a harder way as well. But you wind up just choosing one way and you work through it, and eventually it will wind up working out. You know, as you do more of these problems, you'll figure out what works better, what's easier for you, a general sense of how to get these things done fastest. But really, it's just a matter of practice and just slogging through it sometimes. All right, final example. What if we wanted to solve this system of equations? U plus 2v plus 7w minus 3x plus 4y plus 2z equals 41. And then another one, and then another one, and then another one, and then another one, and then another. Well, notice we've got 1, 2, 3, 4, 5, 6 variables total. And we have 1, 2, 3, 4, 5, 6 equations total. So we know this is possible. So we could solve this system of equations, or at least we could figure out, does it have no solutions? Does it have one solution? Does it have infinitely many solutions? This is horrifying. I don't want to do this. Right? Yuck. Solving this problem with the methods we know now would be possible. We could work through this with elimination. We could work through this with substitution, but it would take us forever to be able to work through this thing. It would be awful. It would be this huge slog. It would just take us so much paper. We could get it done, but I don't want to. And it turns out there's some great ways to do this. We've got some tricks up our sleeves. Later on, when we understand vectors and matrices, we'll be able to see how to solve a monster like this in the lesson using matrices to solve systems of linear equations. You'll be able to use what you know about matrices, matrix multiplication, matrix inverses, things that we'll all learn about in the future, don't worry. You'll be able to learn all of this stuff, and you'll be able to see there's a really, really easy way to be able to just knock this stuff out. If you've got access to a calculator so you can compute the inverses easily, you'll be able to just knock this thing out really, really quickly. Solving this thing will be a piece of cake once we talk through this stuff. So we'll actually come back to this many lessons in the future when we get to using matrices to solve systems of linear equations. We'll take this thing and we'll be able to knock it out like that. It'll be really, really easy to work through, which is pretty darn cool. All right, so I hope that you've got a good idea of how linear systems of linear equations work. It's all about figuring out where the things intersecting in terms of that. That's really the idea of when are these two things going to be true. All right, we'll see you at Educator.com later.